Hello, this is Preeti Kiran. Here I am going to discuss the most basic type of control rectifier. How we can fire it at different firing instance to get the different output voltages. First of all, we will discuss what is an SCR. These are the devices that their output can be controlled by varying the firing angle at the gate terminal. This is a this is a basic one. It is only conducts the positive half cycle because you can see that there is a path for the only one path for the flow of current. The ripple voltage contain high harmonics. For such harmonics, the current drawn by the load inductor will be less. Since the output voltage should not be rich in harmonic, therefore this kind of control rectifier is practically seldom used. Here in this video you can see what is the topology of this kind of rectifier. We have a negative conduction because of L. So what we have is a freewheeling diode which prevents negative conduction during the negative half cycle. In case it is highly inductive circuit, L will not allow the current to change instantaneously. So we should have a low value of inductance. We know that V0, which is the output here, is equals to Vm, the maximum voltage here, Vm by 2 pi into 1 plus cos alpha, where alpha is the firing angle. Now let's go to the simulation here. This is the pulse generator. You can get this in sources. In the pulse generator we have kept amplitude as 1 and the frequency as 50 Hertz. So we have to put this in Hertz. So in time we have to put. So I have kept 1 by 50 Hertz, so that becomes time. Now the main thing is this thing, phase delay. Whenever is the voltage starting here at 0, the pulse, if it starts at 0, the SCR will turn at 0 degree only. Now we want the SCR to fire at 45 degree. So 1 by 50 into 45 by 360 degree, because one complete cycle is 360 degree. If we want to fire at 45, so we are keeping 45 here. Now thyristor, this is a general thyristor we can get in sim power system in the MATLAB. Here in the sim power system you can see power electronics. From that we have got the thyristor, then we have got a diode, then from elements we got a RLC series branch, then from electrical sources we got a voltage source, AC voltage source. Now we have chosen RLC branch, but here we want RL only. So the resistance we have kept as 0.5 ohms and inductance as 65 millihenry, which is quite less. You can say it as nominal. Okay. Now we have to simulate the video. I think we have got enough cycles now, so we can stop. Yeah, this is the output across the RL load. If I want to zoom across x-axis, I can see a few cycles. We can see that at 45 degree the SCR is turned on and the output is going across the load. Yellow one is the output waveform and the purple one is input waveform. Now because of diode we can see that there is no negative half cycle conduction. In negative half cycle there is no output. That is happening because of diode. Now since we are discussing the different firing angles, now let us change a firing angle. Say 60 degree. Okay, run. See, the angle has changed to 60 degree. This is the alpha angle. This full is 180 degree and then this is turning on at 60 degree. Again let us change this to 90 degree. Here you can see the SCR is firing at 90 degrees. Again let us take a last value of alpha. Alpha can be between 0 to 180 degree. This is the main drawback. Yeah. See, the firing angle has become 120 degree now. The output starts here. So the area is reducing as we have seen from 45 degree to 120 degree. We are that the area here is reducing. That means the value V0 is equals to Vm by 2 pi into 1 plus cos alpha is reducing. That is, the output voltage which we are going to get is reducing. That's all we have tried to explain in this simulation. Thank you.